So this next part here, we have to fraction bust to solve this. So if we factor, and this is x times x plus 2. So if we fraction bust, we multiply by x and x plus 2. And then if we distribute here, so this would be x times x plus 2 equals, they both reduce out, so 1, plus the x reduces out, so x minus 1 times x plus 2. And now if we solve this, we have x squared plus 2x equals 1 plus, let's see, so we have x squared plus 2x minus 1x minus 2. So x squared plus 2x equals, combine like terms, negative 1 plus 1x plus x squared. The x squareds would reduce out, so we have 2x equals negative 1 plus 1x minus x minus x. So we end up with x equals negative 1. The next one, again, we have to factor first. So this is x times x plus 1. This one's the same thing. So when we fraction bust, we're multiplying by x times x plus 1. So in the first fraction, they both reduce out, so it's x plus 5. Second fraction, they both reduce out, so it's 1 minus x plus 1 reduces out, so x minus 6 times x. So we have x plus 5 equals 1 minus, this would be x squared minus 6x. So x plus 5 equals 1 minus x squared plus 6x. Quadratic, so let's set it equal to 0. Let's see, minus 6x minus 6x minus 1 minus 1. So we have 0 over here, and we have x squared minus 5x minus 4. Factoring that, x minus 4, oops, that'd be plus 4. And x minus 1, though, multiplies to 4, adds to negative 5. So you have x equals 4 and x equals 1. So now some exponent reviews. So we have to distribute that 2 first. Anything to the 0 power is 1. So we have 2x squared y to the negative 3z times 16x squared divided by 3x to the negative 3y to the 5th. I tend to move negatives first, but 2 times 16, so we got 32. On the top, x to the 4th. Y cubed goes to the bottom, and z. On the bottom, we have that 3x cubed goes to the top, y to the 5th. So simplifying that, we have 32 over 3. We'd have x to the 7th, z on top, and y to the 8th on the bottom. Solving, so we got to get that base by itself, so divide by 4. So we have x to the negative 2/3 equals 9. And then to get x by itself, to the negative 3 over 2 power. Because the 2's reduce out, the 3's are gone, so we have x equals 9 to the negative 3 over 2. It's negative, the exponent, so we move it to the bottom, to the positive 3 over 2. Separate it out, 9 to the half cubed. So that's 1 over 3 cubed, or 1 over 27. So number 9, solving. We got to make bases are the same. So I notice 4 and 32 are both powers of 2. So 2 squared to the 2x minus 1. 1 over 2 to the 5th to the x. So if we distribute here, we got 4x minus 2. I'm going to make that 2 to the negative 5th, so this to get it out of the denominator. So our equation we could write is 4x minus 2 equals negative 5x. Let's see, minus 4x minus 4x, so negative 2 equals negative 9x. So x would be 2/9. So on the back page, these are calculator ones. So solving with logs. Again, when there's x's on both sides, we log each side. And then we bring it out in front. So we have 2x minus 1 log 3 equals 3x plus 4 log 2. And I don't have the calculator here, so then we'd have to turn this into, we could turn these into decimals, and we could distribute and solve and see what you end up with. So the next one here, let's see if we can solve this. So minus 4, 2e to the x minus 1 equals 8. Divide by 2, so e to the x minus 1 equals 4. Let's turn this into a log. So log base e of 4 equals x minus 1. So log base e is the natural log. So the natural log of 4 equals x minus 1. So then we have the natural log of 4 plus 1 equals x. And you could type that into your calculator. Number 12. So we haven't done ones like this before, but we'll use our properties of exponents to figure it out. So we know x equals log 3 and y equals log 5. So we have division. Well, division goes back to subtraction. So the natural log of 5 minus the natural log of 3. Well, right in terms of x minus y, the natural log of 5 is y. So this is just y minus x. And the natural log of 45. Well, let's see, 45. Well, that's the natural log of 3 times 3 times 5, because 9 times 45. So we know multiply goes to adding. So natural log of 3 plus the natural log of 3 plus the natural log of 5. So natural log of 3 is x, so x plus y. So that equals 2x plus y. And then the last two here. So subtraction goes back to division. So this is log base 2 of 8. And we have to evaluate. So I would say let's set it equal to x. And let's write it as an exponent in exponential form. So 2 to the x equals 8. So 2 to what power is 8 is 3. And then the last one. Well, let's write this as we know what equals x. So if we wrote this as a log, it'd be log base 8 of x equals log base 2 of 5. Well, that doesn't help us too much. So let's see, what else do we notice here? Well, I notice this has a base of 2, and 8 can be written as a base of 2. So I wonder if we rewrote this with a base of 2. So 2 to the third to the log base 2 of 5. So now what if we said this equals x? So log base 2 of x equals 3 log base 2 of 5, because that's our exponent. Well, 3 can become up here. So log base 2 of x equals log base 2 of 125. So x has to be 125.